On this problem, we are solving the rational inequality and then graph the solution set on a real number line. Express the solution set in interval notation. So on this one, the first thing that we want to do is solve for it. So we're going to find the values that will solve our inequality. So we're going to take 8x squared minus 8x plus 12, and we're going to set it equal to 0. So we now need to factor this. So we're going to take a times c, which is 1 times 2. Oops, sorry, 12. 1 times 12. And that'll get us 12. And we're trying to get to a negative 8. So I'm going to start with 1 and 12. I got to figure out what my signs are. So because this is negative, this will be negative. And a negative times a negative we need for getting to a positive. So negative 1 times a negative 12 is positive 12, and negative 1 plus a negative 12 is negative 13. Well, that's not negative 8, but we got the sign right. So negative 2 times negative 6 will get us positive 12. And if we add these, negative 2 plus negative 6, we got our negative 8 right there. Now we have a 1 out front, so we can go straight to our parentheses. So that'll get us x minus 2 and x minus 6. All we're doing is rewriting negative 8 with our negative 2 and negative 6 here. All right, so we ought to take each of those and set them equal to 0. So we'll add our 2 over, we get x equal to 2. Add our 6 over, we get x equal to 6. So we're now going to find our boundary points. So I'm going to do our boundary points up here. We always put negative infinity and infinity on our graphs. So we're going to put the numbers that we found when we solved on there. You can put as many numbers as you want on here. I usually just put the numbers that I have to work with. That way I don't have so many numbers I'm looking at trying to figure out what's happening. And basically we're setting up some boundaries here. So I'm going to put our boundary points here, and we're going to put this down to negative infinity to 2, 2 to 6, and 6 to infinity. And now we've got to figure out which group of points will actually work for our problem. So we have to do test points. This is similar to what we do on our asymptotes when we're trying to graph asymptotes. So we are looking at our range from negative infinity to 2, our range from 2 to 6, and our range from 6 to infinity. So those are the ranges we're looking at. And then we're going to pick some points in there. I like to pick numbers that are easy. So between negative infinity and 2, 0 works there. It's the smallest number we can use, and it'll fit nicely into our problem to make our solving easy. Between 2 and 6, I try to go with the smallest number, so that will be 3, and between 6 and infinity will be 7. Now you can choose any number you want in those ranges, but those are going to be the ones that I'm choosing. So now I'm going to plug this back into my original equation. So I have 0 squared minus 8 times 0 plus 12. Well, that's going to get me 0 minus 0 plus 12 is going to get me 12. Now my next number is going to be 3 squared minus 8 times 3 plus 12. Well, 3 squared is going to get me 9. 9 minus 24 plus 12 is actually going to get me negative 3. So negative 3 is our number there. And then on the last one we have 7 squared minus 8 times 7 plus 12 again. Well, this will get us 49 minus 56 plus 12. And when we total that, it will get us to 5. So we're looking to see which ones are actually greater than 0, because then we'll know that those are the ranges we're looking for. Is 12 greater than 0? Why, yes it is. And what about negative 3? Is it greater than 0? No, it's actually less than 0. And 5, is it greater than 0? Yes, it is. So that tells us that our range of numbers will be between negative infinity and 2 and it'll be union with 6 to infinity, which are these two values here that told us that we will get the right numbers to fulfill our equation.